Good day, everyone. This is Fatima Clavesillas, and together with me are Claudine Matulak and Christian J.B. Redesendo. And we are to report our assessment entitled Sea Surface Current Velocity Profile of Sitio Linao, Tinoto, Maasim, Sarangani Province. This is in partial fulfillment of our requirements in MRB 148 Integrated Coastal Marine Resources Management.
Hello, my name is Christian J. Lucendo, and I'm here to show my part of the presentation, which is the abstract and the introduction. So let's begin. Sitio Linao, which can be found in Maasim, Sarangani Province, hosts different marine ecosystems, and the physical movement of water is of significant contribution to its rich marine resources. However, nothing was known about the sea surface currents prevailing in the area. Thus, the assessment was conducted to investigate the sea surface movement in Situlinao. The assessment was done in Situlinao in April 1, 2022. The methods used during the field conduct includes the flow field method using 2-meter cylindrical jogs and a global positioning system, which is known as the GPS. So the maximum flood tide sea surface current speed is 36.46 centimeters per second, which is observed beyond the intertidal flat and reef slopes of Situlinao with a southeastward direction, while the minimum surface current is going southward with a speed of 1.05 centimeters per second, which is found in the inner part of the intertidal flat directly facing the mangrove forest in the area. The average surface current during the flooding tide is 17.4 centimeters per second, while the maximum ebb tide sea surface current speed is 108.52 centimeters per second, which is observed in the southern part beyond the reef slope with a southward direction, while the minimum surface current is going southwestward with a speed of 0.03 centimeters per second, which is found in northern area beyond the mangrove forest and the reef slopes. The average surface current during the ebbing tide is 19.78 centimeters per second. Offshore currents and cross-shore currents are observed during flooding tide, while longshore currents are observed during ebbing tide. These currents may imply that nutrient distribution and possible transport of pollutants. The findings of this assessment will help shape the direction of the integrated management planning that vitally includes solid waste management and water quality improvement and reintegrating policies that local governments will undertake, which in turn benefit the community and the marine ecosystems. And now let's proceed to the introduction. So the ocean is a vast basin that is composed of complex dynamics of features. It covers more than 70% of the planet's surface and is so immensely deep that it contains over 90% of the inhabitable space for life on Earth. Surface currents control the motion of the top 10% of the ocean's water. Current velocity is a key parameter in oceanography, and its direct measurement is important for oceanographic study and environmental monitoring. That is why sea surface current measurements are important for shipping, commercial fishing, recreational boating, and safety. Surface currents also play a role in regulating the planet's weather, climate, oxygen, and temperature. Until recently, in different coastal settings, not much was known about the strength of surface currents, in what direction they flow, how rapid surface water flow patterns change with time or location, how current patterns affect creatures that live in the coastal area, and how currents transport pollutants. The velocity and general pattern of sea surface current in situ now would be beneficial in a way that a key oceanographic information can be obtained, and findings of the assessment will guide local communities and governments for further marine conservation, protection initiatives, and strengthen management efforts. The objectives of this assessment is to describe the direction of the surface current during the ebbing and the flooding part of the tidal cycle, and which part of the study area do the currents move fastest during ebbing and flooding tide, and which portion of the study area has the highest temperature and salinity levels. Significance of the assessment is that this study will serve as a guiding document of the sea surface current velocity profile of Situlinao Barangay Tinoto, Maasim, Sarangani Province during the ebbing and flooding tide. and this may help improve the draft coastal resource management and improve water quality and waste management, as well as findings that would help explain how surface currents affect the nutrient transport and larval dispersion of the area.
So, study site. So, figure 1 shows the map of the Philippines, Mindanao, and the study site, which is the Sicilino, Tinoto, Maasim, Sarangani Province. So, the sea surface current measurement was carried out in Sicilino, Maasim, Sarangani Province on April 1, 2002. So, Sicilino is known for its thick mangrove forest, seagrass beds, intertidal zone, fishes, and coral reefs. In line with the map shown in the previous slide, Table 1 shows the guide waypoints for the sea surface current drug deployment in Sicilino. Here we have the 3 stations, their waypoints, latitudes, longitudes, and bearing. Sampling hours for ebbing and flooding tides are done on specific period of the day as shown in Table 2. The sampling hours are based on WX Tide 32 version 4.7, a tide prediction program. So field measurements and deployment of drugs. Drugs are objects that float on water's surface and move with a surface current. The major assumption is that the drug moves at nearly the same speed as the current. Drugs with only slightly positive buoyancy are more likely to move at the current speed than lighter drugs. That was according to Hodges of 2002. A drug is designed to measure the Langarian water movement at a predetermined fixed depth. It provides in many situations, as suitable means of measuring currents and diffusive properties of coastal waters, estuaries, and lakes. That was according to Grandson and Stevenson of 1977. So, current drugs are made of two metal steel rings attached to each end of a 2-meter long circular GINA earth cloth and suspended vertically in the water by a buoy. Each drug will be released approximately 50 to 80 meters away from each other within the sight of a 2 to 3 meter depth. In the releasing of drugs, the flow field method will be used. That was according to Grandson and Esvenson of 1977. It will be released in succession following the mapped sampling stations. Drugs will be retrieved immediately 10 to 15 minutes after the first drug is deployed, traversing the same path of the drug deployment. Using a handheld global positioning system, coordinate points will be recorded. Also, temperature and salinity at certain points in the station will be recorded. In addition to analyzing the current pattern, different coastal currents will also be observed and recorded. So, Table 3 shows the different coastal currents utilized to determine current patterns. So, those coastal currents are the longshore current, offshore current, cross-shore current, and reef currents. Data analysis. So according to Joseph of 2014, the Langorian method of fluid dynamics will be used in measuring the current velocities, since this method provides a quantitative description of both track and speed of flow, as if often employed to obtain an overall picture of oceanic water currents over large areas. The graphical presentation of the measured current will be plotted using Golden's Software's surface mapping software, Surfer version 20, and the distance and angle against north calculation will be computed using a map source. Current velocities will be plotted as two grid vector maps with polar coordinate system. Kriging method of gridding that was according to Bolling of 2005 will be used. The plotted vector maps will be overlaid to real satellite aerial images from Google Earth Pro of 2020. The post map of the bay will be also plotted using the same Surfer version 20 to determine the location of the drug deployment. Descriptive statistics were computed after the data are processed using Microsoft Excel to calculate the minimum, maximum, and average current speed for Citrullina during the said monsoonal period. Current velocities were expressed in centimeters per second as per Mel of 1980. The data for ebbing tide and flooding tide sea surface current of Citrullina are plotted through Google Earth Pro to picture out the overall track of drugs all over the area. The path of every drug indicates the movement of sea surface current.
As for the results and discussions of this assessment, sea surface current prevailing in Sitio Linao, Barangay Tinoto, Maasim, Sarangani Province, on the flooding and ebbing part of the tidal cycle using cylindrical drogues was investigated. For the whole duration of the conduct, there is a total of 26 drogue deployments in the whole stations for flooding tide. Approximate total duration of sea surface current sampling during the flooding tide was 2 to 3 hours. On the other hand, there is a total of 19 drogue deployments for ebbing tide. The approximate total duration for the sampling during ebbing tide was 2 to 3 hours. During flooding tide, the maximum temperature is 29.8 degrees Celsius, while the minimum temperature is 26 degrees Celsius. The average sea surface temperature during flooding tide is 28.28 degrees Celsius. The minimum, maximum, and average sea surface salinity of Sitio Linao during flooding tide are shown in Table 6. The maximum salinity is 33.1 ppt, while the minimum salinity is 29.6 ppt. The average sea surface salinity during flooding tide is 31.53 ppt. During the ebbing tide, the maximum salinity is 31 ppt, while the minimum salinity is 27.9 ppt. The average sea surface salinity during ebbing tide is 29.51 parts per thousand. As you can see, we have our sea surface current velocity results through our table and figure. So the minimum, maximum, and average sea surface current speed of Situlina during flooding tide are shown in Table 8. The maximum current speed is 36.46 centimeters per second, which is observed beyond the intertidal flat and the reef slopes of Situlina, with a southeastward direction, while the minimum surface current is going southward with a speed of 1.05 centimeters per second, which is found in the inner part of the intertidal flat directly facing the mangrove forests in the area. So please see figure 1. The average sea surface current during the flooding tide is 17.04 centimeters per second. On the other hand, the minimum, maximum, and average sea surface current speed of in Sitio Linao during ebbing tide are shown in Table 9. The maximum current speed is 108.52 centimeters per second, which is observed in the southern part beyond the reef slope with a southward direction, while the minimum surface current is going southeastward with a speed of 0.03 centimeters per second. And this is found in the northern area beyond the mangrove forests and reef slopes. The average surface current during the ebbing tide in Situlina is 19.78 centimeters per second. Currents may be referred to according to their forcing mechanism as either wind-driven or thermohaline. Alternatively, they may be classified according to their depth, surface, intermediate, deep, or bottom. In a coastal setting, currents are highly significant for the larvae generation and distribution, where these are highly concentrated, as well as the nutrients, pollutants, and sediments pulled from the coastal runoff are introduced and circulated into the open ocean. The coastal areas are highly influenced by the rise and fall of tides and the wind stress that flow alongshore and offshore, as observed During flooding tide, there are longshore currents in the offshore region that is directed southward. In the inner portions of Sitio currents go in an inward manner, westwardly, following the contour of the shallow intertidal flat. This eventually become cross shore currents, and this could be due to the wind blowing in the certain area and the feature of the whole intertidal flat. On the other hand, longshore currents are mainly observed during ebbing tide. This current ran parallel to the shore, which ranges from 18.19 centimeters per second to 35 centimeters per second, flowing southward. The cross-shore currents observed during falling tide and the longshore currents noted during both tidal cycle may imply that these currents can carry and distribute possible nutrients. In the case of both tidal cycles, where longshore currents are observed at the offshore region, nutrients and possible pollutants may be carried southward. Conclusion and recommendations. So for our conclusions, first, flooding tide sea surface currents of Sitio has an average speed of 17.04 centimeters per second, which is found in the southern portion beyond the reef slopes. During flooding tide, cross-shore currents and longshore currents are observed in the area. Ebbing tide sea surface current has an average of 19.78 centimeters per second. It is observed beyond the reef slopes in the southern portion, which is the same with the flooding tide. Longshore currents are dominantly observed in the area. These currents, especially the longshore current, flow southwardly and vital for the distribution of nutrients in the area. The current flow during ebbing and flooding tide may be due to the tide's wind direction, underwater topography, and other affecting variables that can alter the sea surface velocity. Average sea surface temperature during flooding and ebbing tides are 17.04 degrees Celsius and 19.78 degrees Celsius, respectively. The average sea surface salinity during flooding tide and ebbing tide are 31.53 ppt and 29.51 ppt, respectively. It is highly recommended that this surface current profiling be observed thoroughly, and further studies correlated with satellite imaging should be employed, especially by the concerned agencies and organizations, both public and private, as well as the local government, in order to achieve a more detailed surface current information in the coastal areas, not only in situ Linao. Subsurface current measurements should also be conducted alongside surface currents in order to find out the interaction of the two. The contribution of concerned public and private institutions can achieve a more detailed result and assessment on the current pattern and its influence to nutrient dispersion, water quality, and other scientific aspects of sitio Linao. With that said, resource management and solid waste management not only in situ Linao but the whole coastal waters of Sarangani Bay will be even more strengthened. Furthermore, this study should be updated annually in order to generate a trending report, especially for both southwest and northeast monsoons. The following photos or videos that will be shown are the group's documentations for the whole duration of the sea surface current conduct in situ Linao.
Drop. Taro nga lang. Taro nga lang. Sige, taro nga lang. Sige, hulog na siyang isa.
Last na yun nga drog, no?
Naa pa. Patindoga, patindoga. Sige. Sagdi lang, sige lang. Matindoga na yan. Sige.
Let's go!
Sige, dito ya.
Ikaw na ni Batio.